Snapple fact number 351. Cold water weighs less than hot water. Let's talk about that. I left this Snapple bottle in the freezer overnight, and it is completely frozen solid. Like, that's a solid block. But that doesn't mean that just because it's colder, it weighs less than this, if it were full, of course. It doesn't mean that just because it got cold, it weighs less than this. They still weigh the same because there's the same amount of stuff in it. It's just in a different form. This is solid, this is liquid. What's cool about water, which of course Snapple is mostly water, is that when it freezes, it becomes a crystal. That's right. Ice is a crystal. And that doesn't mean that it's a pretty, glimmery, expensive gemstone. A crystal is anything that has a regular geometric structure. So if I were to look at ice under a microscope, it would have a repeating structure of geometric shapes. This is true for anything that you would call a crystal. So like emeralds and amethysts, that sort of stuff. What's interesting about water when it crystallizes into ice is that you can't really see it here, but when it freezes, the bottle sort of bulges out a little bit more. You can try this yourself. If you freeze a bottle of water, it kind of like expands a little bit because the exact precise structure, the crystalline structure of ice, has the molecules further apart than water is in its liquid form. So the molecules all separate and spread out a little bit, and it makes the bottle bulge a little. This is something that's actually unique to water. Most liquids contract when they freeze. Water expands. Because of this, it makes the water less dense when it's in solid form. So if you have the same volume, if I have 1 cubic liter of water and I have 1 cubic liter of frozen water, of ice, then the liquid water will weigh more because it is denser. The molecules are more closely packed than the molecules are in the ice. That's not bad. You guys should try this.